Today, what we're going to be talking about are angles in polygons. And the definition of a polygon is just a sided shape, a many-sided shape. So for example, the triangles we just got done studying, those were a type of polygons, or type of polygon that has three sides. So a three-sided polygon is a triangle. A four-sided shape, we know some four-sided shapes like rectangles, squares, and all that, but generally it's a quadrilateral. A five-sided shape is a pentagon. A six-sided shape is a hexagon. A seven-sided shape is a heptagon. 8 sides is an octagon. 9 is called a nonagon. 10 is called a decagon. 12 is a dodecagon. And for any other number of sides, we just call it an n-gon. So, for example, an 11-sided figure, yes, there's a special name for it, but we're just going to call it an 11-gon. Now, of these, the ones that you should really know are an octagon, hexagon, pentagon, quadrilateral, and you already know triangle. So these are the major ones that you should know. Now, when the sides of a triangle or any shape are extended, the three original angles of the triangle are called interior angles. They're on the inside. Interior angles. Now, the sides of the triangle are extended. The angles that are adjacent or next to the interior angles are called exterior angles. Now, a polygon that has all of its interior angles congruent, we call that equiangular. Equiangular. All the angles are the same. When all sides are congruent, we call that equilateral. Now, when we were talking about triangles, we talked about equilateral and equiangular triangles, but this applies to all shapes. For example, a rectangle, all the angles in a rectangle are 90 degrees, so that would be equiangular. However, all the sides are not the same length in a rectangle, so it would not be equilateral. If a polygon is equilateral and equiangular, we just call that regular. So for example, an equilateral triangle we know are triangles that have all sides that are the same length and all angles are 60 degrees. So we would call that a regular triangle. All the sides are congruent to each other and all the angles are congruent to each other. In a polygon, we have two vertices that are endpoints of the same side are called adjacent vertices. So like over here, A and E, they're the endpoints of AE. These are adjacent vertices. Now, a diagonal of a polygon is a segment that joins two non-adjacent vertices. So example, from B, the diagonals from B are BD and BE. BC, that is not going to be a diagonal. That's actually a side. This is a side of the shape where the ones that go through it are called diagonals. Now, on the next page here, we're going to do this exploration a little bit to just kind of see where we're going. So a triangle has three sides. Well, how many triangles can we make by connecting vertices? Well, we can't. I mean, yes, you could say, well, can't we make a triangle right here? and now we have two triangles. I agree with that, but we're going to draw diagonals from one vertex. So there are no non-adjacent vertices in this triangle. So there's only one triangle, and we know that the sum of the measures of the interior angles is 180 degrees in a triangle. Now, if we had a quadrilateral, see, we can create one diagonal from this point. And now we have two triangles. So it's four sides, two triangles. Well, each triangle is 180 degrees. So there's a total of 360 degrees in a quadrilateral. Now a pentagon, so we pick one of the vertices and draw any diagonals. This gives us 1, 2, 3 triangles. So 5 sides, 3 triangles, 540 degrees. And then a hexagon, a 6-sided shape. Okay, there's one diagonal, 2 diagonals, 3 diagonals. So 1, 2, 3, 4 triangles. So 6 sides, 4 triangles. 4 times 180 is 720 degrees. Okay, so you can see the relationship here that the number of triangles in these shapes is going to be the number of sides minus 2. 5 minus 2 is 3. Well, then if we have 3 triangles, we multiply 3 by 180. So what that gives us is a formula down here. The sum of the measures of the interior angles of a convex n-gon or any polygon is n minus 2 times 180, where n right here is the number of sides. Well, we can extend that to any shape, but one that you should really memorize is that a quadrilateral always adds up to 360 degrees, because later on in this unit we're going to be focusing solely on quadrilaterals, and it's good to just memorize that the angles always add up to 360 degrees in a quadrilateral. So down here we're going to find the sum of angle measures in the polygon below. A heptagon, in a heptagon, n is equal to 7. So we're going to use that formula, 7 minus 2 times 180. Now, you want to make sure that in your calculator, you put 7 minus 2 in parentheses. 7 minus 2 times 180, and that's going to be 900 degrees. A nonagon, in a nonagon, that's 9 sides, so n equals 9. So 9 minus 2 times 180. Now if we type that in the calculator, let's see what we get. We get 1,260. Now it's important to note that we don't know what each angle in this nonagon is equal to, but we know that all the angles have to add up to 1,260 degrees. Now a 22gon, n equals 22. So we're going to have 22 minus 2 times 180, and that's going to give us 3,600 degrees. So down here, we're going to go backwards. I'm giving you how many degrees the angles add up to. We're going to figure out how many sides this has. So 1,080 equals n minus 2 times 180. So we're going to divide both sides by 180. 1,080 divided by 180 is 6. So 6 equals n minus 2. We add 2 to both sides, 8 equals n. And we know that an 8-sided shape is called an octagon. Now, letter B, we know the angles add up to 1,440. So 1,440 equals n minus 2 times 180. divide both sides by 180. So that's going to give us 8 is equal to n minus 2. And then we add 2 to both sides, we get 10 is equal to n, which is a decagon. Now 3,420, okay, so we're going to do the same thing. Divide both sides by 180, and then if I type this into the calculator, I get 19. So 19 equals n minus 2, and we add 2 to both sides, 21 equals n. Well, we don't have a special name for that, so we call it 21 gon. All right, so on these problems here, we can see that this is a four-sided shape. So these four angles must add to 360 degrees. Oops, plus x equals 180. So if I were to add up 135, 112, and 71, that gives me 318. So 318 plus x equals 180. And when I subtract 318 from both sides, I'm sorry, not 180, I'm sorry, this is supposed to equal 360. We're just going to start over. All right, so in this problem, we know it's a quadrilateral because there's four sides, and these four sides have to add up to 360. So x plus 135 plus 112 plus 71 equals 360 degrees. So x plus, and when I add up these numbers, I get 318. And then when I subtract 318 from both sides, x is equal to 42. So x is 42 degrees. Now in example 4, what we have going on is we have a five-sided shape. Well, if you don't remember from our activity above that 5 sides, the sum of those interior angles adds up to 540, you could always do our formula. Oh, 540. Okay, so now we know if we add up these angles, but these two angles here, well, they're congruent to each other, so they got to be the same measure. We can call them x. And that equals 540. So we're going to add up 68 plus 105 plus 109 and get 282. So 282 plus 2x equals 540. Well, 540 minus 282 gives us 258. Minus 282 from both sides. So you get 2x equals 258. And then we're going to divide both sides by 2. And x is equal to 129 degrees. So yeah, this lesson isn't too difficult as long as you remember to use the formula and remember which way we're going, either forward or backwards, depending on what we're asking, and always make sure to use that formula when needed. So thanks for watching. Make sure to like the video and subscribe.